Today we're going to get into proving things, okay? Now, when you prove something, you actually don't get to use the actual, if I said, okay, we got to prove that this person's guilty of murder, and you're the lawyer that's trying to convict this person, you can't just say, I know they're guilty, I know they did it. The judge, the jury, everybody wants, prove it, right? Well, you can't prove it, you weren't there. So how do you prove that that person murdered that person? And you weren't there. So how can you prove it? Evidence. What kind of evidence would you look for? Fingerprints. Alibi. Did other people see that person entering the... That stuff, you are not saying I was there. You're not saying I saw, and even, this is weird, if you saw the murder with your own eyes, and you're the person that's trying to prove it, you don't get to use you. No. So, it's like then you have to find other people that saw, and then no one did. It's like, okay, if, and this happens, you'll probably see it more now, but if you're driving around, you may see a sign that said, if you saw an accident here on April 10th at this time, can you please call me? Now, what are they looking for? They're looking for witnesses, right? They're looking for witnesses, even though you were there. You were in the accident. This guy hit me. He came out of nowhere and hit me. I was there. You know, Your Honor, I swear I saw it. They're going to be like, I know, but you got to give us some proof. If you get some random stranger you don't even know that'll testify they saw it too, you're going to win the case. You don't get to use you, okay? So when you're proving things in here, you can't just say, it is. I just know it is, okay? You can't do that. So if I could just give you one example that I want to talk about here. And so you don't have to write this down. I want you to watch. Okay. What is 5 to the 0? Anyone remember? It's 1. What is 10 to the 0? 1. So anything to the 0 is 1, right? But I'll have students that'll say 5 to the 0 is 0. Or 5 to the 0 is 5. Now, how can you prove, and you don't get to say because my calculator does it. When I put 5 to the 0 in, it does it. But how can you prove that 5 to the 0 equals 1? And you can't just say, that's a rule. That's a rule they told us. You know, Miss So-and-so in grade 5 told me that. So that's why 5 to the 0 equals 1. You can't do that. You have to prove it. So I'm going to prove it, and I'm not allowed to use the fact that anything to the 0 power equals 1. I want to prove that rule. Now, what if I use other things? Now, what is 7 divided by 7? Okay. What's 14 divided by 14? Okay. So what am I saying here? What rule is this? 50 divided by 50. A divided by A. What is this rule? Okay, anything, so I should probably spell it right. Anything divided by itself equals 1. So I would say to the jury, do you agree with this? They don't agree that 5 to the 0 equals 1. They don't agree with that. But I'm going to say, do you agree with this? And they would go, okay, yeah, I know that. I know that rule, that anything divided by itself equals 1. Okay? And I would be cool. So you're with me on that. And they're like, yeah, I'm with you. So I said, can I try another rule? What would be a to the 6 over a to the 2? Does anybody know what that equals? Do you remember all the way to last year? What happens when you divide powers? You subtract the exponents. Do you remember that rule? This would be a to the 4. Okay? So if you had, you know, like x to the 6 over x to the 3, what would be the answer? X to the 3, right? You know, if I did b to the 16 over b to the 3, what would it be? B to the 13. So what is the rule, the math rule that I'm talking about here? When you divide powers with the same base, you subtract the exponents. Okay? So when you divide powers with the same base, you subtract exponents. And when you multiply, you add exponents. Do you remember that? Okay? Now, I would say, so, to the jury, I'd go, do you agree with this rule? And they would go, yeah. I mean, that's a rule. And do you agree with this rule? And they would go, yeah. And I go, I will use both of these to prove this is true. Okay? Because using this rule right here, let's just talk about this rule. What would be a to the 6 divided by a to the 6? What would be the answer? It would be 1. You already agreed with me that anything divided by itself equals 1. Right? Is that not true? A to the 6 divided by a to the 6 should equal 1. Okay? Now, by this rule, a to the 6 over a to the 6, what would it be using this rule? Proving that a to the 6 over a to the 6, since this equals a to the 0, must also equal 1. See, I proved it. And I did not keep saying, this is just a rule. You should just know this. Anything to the 0 power. But students want to know why. And I go, okay, well, this is why. Because anything divided by itself equals 1. And anything when you divide, you subtract exponents. So both of these are true. Therefore, these must be true. That's a proof. Okay? And if you ever watch, like, I don't know, I like, good investigative, movies or whatever. And when they make that final statement at the end to prove why he did it, then everybody's like, oh, has to be. Okay, now it all makes sense. Right? Like there's that movie out now called Knives Out. Anybody seen it? It's one of those, right? It's a brand new movie, and it's like through the whole movie, you have to figure out who did it, right? And of course, at the end, you find out. But that whole time, it's just good to be putting all the stuff together. You're thinking one way, and then they show you it's not, right? Because, right? Those are fun. I think they're fun. And proofs, it's weird. Like in university, I had to take a course of just all proofs, and sometimes to prove the simplest thing is the hardest. And sometimes it takes like 2 pages. Okay? And sometimes we just want to say, well, that's just a rule. Like everybody knows that. Why do I have to prove it? Okay? So today you're going to be proving things you already know. But you need to prove it by not just using that rule over and over. Like, well, those two have to be equal. They're opposite. We learned that. No, you can't use that. Why are those opposite angles equal? Okay? So let's try and start to see what I'm talking about. So let's go to page 120 actually. And we're going to come right down to here. So we're going to use deductive reasoning. That was deductive reasoning that I did with you. Is this true? Is this true? Then if these are both true, then this would be true. Okay? Now, here we'll use the following facts. Just like when I did my proof, those were all facts. Right? I didn't make anything up. Now, angles on one side of a straight angle or a straight line are supplementary. They add up to 180. Okay? So that's saying that if you have a line, x plus y must add up to 180. Okay? That is a fact. Vertically opposite angles are equal. If you got 2, then this equals this. That's a fact. Now, if two parallel lines are intersected by a transversal, so I got two parallel lines and they're intersected by a transversal, corresponding angles are equal. Okay, those are all facts. Okay, so here's a question. Prove that angle 1 equals angle 7. So I need to prove these are the same. Angle 1 and angle 7. I have to prove they're the same. Now, haven't we already learned that in the z, those two must be equal? Remember that yesterday? The z, these should be equal angles. But we need to prove it. And you can't just say, but no, we learned that yesterday. No. Let's prove just using these. So the first thing you could start off with is by saying angle 1 equals angle 3. Is that true? Based on what? Oh, cool. Thank you. Sure, just right there. Thanks. Okay. Angle 1 equals angle 3 because they are, so we can say vertically opposite. So I have proved that these are, I'm saying these two are equal. And then I can say angle 3 equals angle 7. Why? So they are corresponding angles. So now that I've proven 1 equals 3 and 3 equals 7, have I not now proven that 1 equals 7? Okay, so angle 1 equals 7. You don't have to say the transitive property. And so therefore, I like to use a therefore, they're both equal angle 3. So 1 equals 3, 7 equals 3, therefore 1 must equal 7. And that's what you can use sometimes to even help you verify stuff. Oh, I'm pretty sure that Z thing, should these be equal? Okay, well these are for sure, and these are, oh well, yeah, they are equal. Okay, do you see how you come around to get to prove it? You don't just say, well 1 equals 7. I just know that, right? Well, it's like if I asked you, prove to me 1 plus 1 equals 2, those are hard proofs, okay? So you have to prove another way to show that that's true. And you can't go, well 2 plus 2 is 4. Well no, that's just another example of what you're doing. Okay? Let's look at this top one. Whoa. Where am I here? Things just got weird. Okay, here we are. We're at this one. Prove that angle 1 plus angle 4 equals 180. This is what I need to prove. Now, they're saying, they're starting us off. 1 plus 2 equals 180. What would be the reason for that? Straight angle, right? Or straight, yeah. Straight line or straight angle. Okay, so that's legit. These two equal 180. Now angle 2 equals angle 4. Why? Not corresponding. 2 and 3, no, not even 2 and 3, sorry. 2 and down here would be corresponding, right? Under the line, under the line. 2 and 4 are not corresponding. They are alternate angles. See, we couldn't use alternate angles on the last one. We were trying to prove it. But now we can use alternate angles. So they are alternate. So if 1 and 2 equal 180, and angle 2 equals angle 4, we can say angle 1 plus angle 4 must equal 180. Why? Because since angle 2 equals angle 4. See, if 1 and 2 equals 180 and 2 equals 4, 1 and 4 should equal 180, right? Are you seeing that? Are you picking up what I'm putting down here? Okay, so I want to do a really hard one now. Let's go to question 4. We'll do question 4 together. This one's cool because we haven't been given anything. So what I need to do, it says use deductive reasoning to prove the sum of the exterior angles equals 360. So the exterior angles are x, y, and z. So I need to prove x plus y plus z equals 360 degrees. So this is probably something you didn't even know. Okay. So this is a good one. Now, what do I know? What does A equal? So maybe the first time you see this, you're like, I wouldn't have thought of that. But A equals 180 degrees minus x. Do you agree with that statement? A equals 180 minus x. So then we can say that B equals 180 degrees minus x. Or no, y in that case, sorry. Okay. And then C would equal 180 minus z, right? You know, I even see a way better way to do this one. Okay. So I want to switch. Why don't we do it this way? X would equal 180 minus a. It's basically just switching these algebraically, because x would equal that. Y would equal 180 degrees minus b. And z equals 180 minus a. So let's cross this one out. We don't need that one. Now I need to prove that x plus y plus z equals 180. Or x plus y plus z equals 360. Sorry. Now, okay, what else do I know is true? Very nice. I know for sure that a plus b plus c must add up to 180 degrees, right? So that's why I actually know why I did this. So did everybody cross this out? We need it now. It'll be easier if we use this, okay? So all you do is you hit your back button a bunch of times. Like it never happened. Okay, but we need this still. A plus B plus C equals 180. Okay, so are these facts? Are these true? They have to be true. Remember when we were doing deductive reasoning last? If one of the statements was false, and then you make a conclusion off it, it's going to be wrong. But are these true? Okay, so instead of A, now what does A equal? It equals 180 minus x, doesn't it? Look, A equals 1. So I'm going to take A and I'm going to substitute it with 180 minus x. Because that's what A is, 180 minus x. Plus, now what does B equal? (180 minus y). I'm just doing substitution because this was all true. So I can substitute, and I can substitute C with 180 minus z, and this should all equal 180 degrees, right? So all we did was substitute these two things together. You see what I did? This three true statements and one true statement. A is 180 minus x. B is, right, 180 minus y. And then, of course, this just stayed here. Now, now we can get rid of the brackets and we can add this up. 180 plus 180 plus 180 is 540 degrees. And then it'd be minus x minus y minus z equals 180. Now, what if I want to bring these to the other side? What would they become? Right, so I could add x, add y, add z. So then I would get 540 degrees equals 180 degrees plus x plus y plus z. Okay, now almost done. What should I do next? Subtract 180 to both sides, which equals 360 degrees equals x plus y plus z. Did I not just prove x plus y plus z equals 360? So I could go, therefore, the sum of the exterior angles x, y, and z equals 360 degrees. So I took factual statements and proved that the exterior angles equal 360. They're very satisfying when you get these. We do a lot in 30-1 too, and sometimes they take like a whole whiteboard, but students are pretty, and that's what they'll say. It's very satisfying when you get those. Okay, so you're working on, if we come back here, 3, 6, 7, 9, and 10. So again, some people, proofs are like a fish in water, right? They're just like, oh yeah, those make so much sense. And some people, they don't like the logical, right? And it's that part of that brain we've been working on by doing all those problems when we're finished. And the last 2 units, let's face it, it's all on that deductive reasoning, right? Prove it, right? And it's not as easy as you think. In fact, to prove 1 plus 1 equals 2, it's not, you can't just put down two things and say count them. Okay? How do you prove it? It's a lot harder than you think.